Okay, hi there. Today I'm going to be covering chapter 12-6 for Algebra 1, Permutations and Factorial. So let me start with factorial. The exclamation point in math refers to factorial, okay? And what that means is whatever number is before it. So suppose I took like 4 factorial, for example. You know, this is the same as the numbers starting at 4 and going all the way down to 1 multiplied together. So 4 times 3 times 2 times 1, all right? The 1 is almost redundant in some ways because 1 times anything is itself. But, you know, so if I gave you 4 factorial and I asked for what that is and simplify it, 4 times 3 is 12, and 12 times 2 is 24, and 24 times 1 is 24. So that would be the answer, okay? So that's the idea of that one. If you took 5 factorial, that would be 5 times 4 times 3 times 2 times 1, all right? And if you did that in your calculator, you get 120, okay? Okay, so that's basics on factorial, and you see problems with that sometimes. For example, you know, if I said, suppose you're making a line with 7 students. How many orders can you make the line? All right, so you remember those days back in elementary school where they'd tell you to line up at the door, we're going to gym class or going out to recess or whatever. Of course, it was most important who was first. So, you know, the way this works and the reason why this is a good factorial kind of problem is because, you know, you got 7 kids and only one of them can be first, but there's any one of them could be first, theoretically. So I got 7 possibilities for kids that can be first. Once I figure that out, we're trying to figure out who's second in line, and you know, there's 1 kid that's first, which means there's 6 kids that are next in line, could be next in line. And now I figured out who's first in line, who's second in line, who's third in line comes next, which means there's 5 possibilities left because I figured out who's first and who's second. And of course, you can see where this is going. Next, I figured out, you know, who's first, who's second, who's third, which means there are 4 possibilities left for who's going to be fourth. And of course, then there are 3 possibilities for who's going to be, where am I at, fifth. And once I figure out who's first, who's second, who's third, fourth, and fifth, then there's only 2 possibilities left. And of course, there's 1 poor kid who's going to be last. He doesn't have a choice about it. So the number of actual ways that you can do the line is if you multiply all those together. And of course, that turns out to be your 7 factorial button. 7 factorial will be your answer, which in this case, 7 factorial is 5,000. 7 factorial is 5,040. So there's 5,040 different ways to make that line with 7 kids, and that's where, you know, order is very important. Which brings me to the next thing we're talking about is going to be permutations, and this is super important. I'm going to put a star next to it. Permutations is where order matters. All right, now permutations also has a formula. It's this one, PNR equals n factorial over n minus r factorial. And with this, n is the number of objects arranged. and R is at a time. So I'll show you how to work that in a second. Number 1. A band has 7 songs and wants to put 5 songs on a CD. How many arrangements of the 5 songs are possible? Okay, so this one, I'm going back to my formula P and R, NPR, whatever, equals n factorial over n minus r factorial. Okay, so obviously order matters with this. You know, it says arrangements. That might tip you off. That's probably an important word. But you know, you can also take into consideration the context. You know, we're doing a CD. Certainly, which song is first is important. Which song is second is important. You can ask yourself that too. You know, which number is going to be n and which one's going to be r? I've been doing this a long time, and what always ends up happening is n turns out to be the bigger number every time. And every time r turns out to be the smaller number. And I know that's not the way I defined it up above, but it really works pretty much every time. I haven't seen it not work. So when I say the 2 numbers, that means, you know, I got 7 songs and we're putting 5 on a CD. So those are my 2 numbers. So the only way this formula actually works mathematically is if n turns out to be the bigger number. So that in this case, it's going to be 7 is the bigger number, 5 is the smaller one. Now let me plug those into my formula and we can solve it. So this would be 7p5 equals n is the bigger number, so that's 7 factorial over 7 minus 5 factorial. Okay, now if I simplify that, I got the top is 7 factorial and 7 minus 5 is 2 factorial. So what this actually turns out to be is 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1. Now, there's a nice thing that happens when mathematics, when you have a number in the top of the fraction and a number in the bottom, they cancel out, which means my answer is going to be 7 times 6 times 5 times 4 times 3. And if you punch that into your calculator, you get 2,520 arrangements. Some calculators also have factorial buttons. You know, if you type in 7 factorial into your calculator and then divide it by 2 factorial, you will also get 2520. So that's another way to do it. Usually it looks like this in your calculator, X, and then the exclamation point. So you can play with that on your own and figure that out. Okay, number 2. You bring 10 books on vacation and you are going to read 6 books. How many orders could you read the books? All right, so we need to talk about some of the vocabulary stuff here. Because I know I'm saying, you know, order matters with permutations, and I know I haven't gotten into the other part yet, which is called combinations, which comes in the next video. And combinations where order doesn't matter. So it's important for us to start recognizing it now about which words we're using to indicate order mattering. In this case, clearly order is the word that sticks out, okay? So the other thing is obviously we got the 10 here and 6. So those are really the most important parts out of that word problem that I'm going to need. And I know already that I'm going to use the permutation formula. Okay, and n, 10 and 6 are going to be n and r. Remember, the 10 is going to be the bigger number, so that goes in for n. So I got 10 factorial over 10 minus 6 factorial. And if I simplify this out, I get 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, that's 4 factorial. 10 minus 6 is 4. 4 times 3 times 2 times 1. 4, 3, 2, 1. Which means when I multiply those together, I will get my answer. 10 times 9 times 8 times 7 times 6 times 5. And you miraculously get 151,200 different orders. And that's the answer. Now, for a couple of these, sometimes we'll just give you the simple formula here plugged in like that. In which case you're going to go, I'm going to make this one a U try. I'm going to give you 2 U tries. This is the first one, so you can plug that into the formula. You know n is going to be 10 and r will be 4. Okay, and the second one, so that one's a U try. Now I'm going to do number 4, and then I'll give you another U try with number 5. Now I like doing one of these. I like seeing kids, try to use their math skills as opposed to just punching things into calculators. So usually I can pick a number big enough to overload your calculator. I put these on quizzes and tests sometimes, so be wary. If I plug this in to the formula, I get 90 factorial over 90 minus 4 factorial, which turns out to be 90 factorial over 86 factorial. Now, if you do this out by hand, you're going 90 times 89 times 88 times 87, 86, 85, and there's a ton of numbers there. So there's actually a nice kind of math tool to do, and it's this. So if I take 90, right, and I start going down, times 89, times 88, times 87, times 86. Now I see in the bottom of this fraction, I got this 86 factorial. So if I actually stop there, instead of going all the way down to 1, if I go like that and stop at 86, I can do that same magic, wonderful trick in math where you just cancel out what's in the top and the bottom. And then I only have to multiply these 4 numbers together and I get my answer, all right? And if you take your calculator, go 90 times 89 times 88 times 87. It's still a really big number, but it saved me a lot of time. 6, 1, 3, 2, 4, 5, 6, 0, which is still in the 61 million category, but certainly much smaller than, or much easier if you do it that way. All right, so that's that problem. Here's the last one, which will be a U try. You can do that one. I would suggest doing it my way, all right, where you stretch it out a little bit and then cancel out with the denominator, okay? And you can bring that to class with you and have a great night. I'm going to close it out with some more music.